So last night, it was December 31st, 2023. It was the new year, and I uploaded a video of using the 7-segment display, this quad 7-segment display, in order to display the year changing over from 2023 to 2024. And I wanted to make a bit of a tutorial on how you can actually use one of these quad 7-segment displays to display any 4 numbers you want. So that's what this is going to be about. So in order to actually design this thing, we need to talk about its pinout. So future me, editing me, is hopefully going to throw a picture on screen showing the pinout of this 7-segment display. And as you can see, 8 of the pins are used for controlling the 7 segments plus the decimal point, and then 4 of the pins are used for controlling each of the displays. So I'm going to show you what that kind of means, and I'm actually going to wire it up. Alright, so now I have a very basic circuit wired up. Sorry, if you don't look at the bottom yet, that's a spoiler. So this is just activating the middle segment. This red wire is going to the, is what's controlling the segment, so it's actually delivering power, and then this white wire is just acting as a ground. And what you'll notice is that when I move the ground to the different pins, it changes the segment that I'm controlling. So now I'm controlling this segment, now I'm controlling this segment, and now I'm controlling this segment. And this allows us to control each segment independently, except for the fact that it kind of doesn't. As you can see, when I attach more than one wire, now I'm controlling both of these segments, which means that whenever I change the segment I'm using, I'm controlling both segments simultaneously instead of independently, which is kind of upsetting if we want to display any number that has different numbers in it. However, this bug is more of a feature, really, because what we can do is, we can actually cycle these. So we can quickly swap between these two in order to control them independently. So I'll show you how we can actually do that and how we can program that and implement it. So this is a board that I've wired just so I don't need to do it on camera, but really it's nothing too complicated. Each of these resistors is going to be taking an input. They're just limiting current to the LEDs, and then each of these blue wires is is controlling which display we turn on. Sorry, that was a bad. So we're just going to put this in here, and then we're going to connect the arduino to it. Oh shoot, no, wait, ignore this. Alright, let's try that again. So we're going to put this in here, like so. Hopefully it actually fits in. Look at that, I know how to do this. And then it's going to, basically, sorry, I should rephrase. Each one of these resistors is going to take an input that's going to control a segment of each display. So the yellow wires are controlling the segments themselves, and then the blue wires, as you can see, there are 4 of them, 1, 2, 3, 4, are controlling which display we turn on. Now, we can turn on the displays electronically using our good old friend, the transistor. So this is just a 2N22A transistor, 2N2222A, sorry, and these are, you could find them anywhere, but any transistor will do. These ones are just tiny and they don't make too much of a mess, so you can just wire them into each of these blue wires that are connected to ground, and look at that, like a work of art. And then you can also wire in the resistors to the base of the transistors. And I'm just going to skip this part because it's not going to be interesting to watch that. Alright, so now that I actually have everything wired up, well, sort of, I have the resistors wired up, now we're going to attach the fruit roll-up. We're going to attach the fruit roll-up to the Arduino Uno and connect it down here. So there are 7 colors on this one, and each of these colors is going to control one of these resistors, which is in turn going to control one of the 7 segments. So I'm going to use 0 through 6 and connect it, and I'll be back with you in a second. Alright, so now it's actually gotten back in. And if you're doing this at home, make sure, absolutely make sure that these wires are wired in correctly, or else you're going to get really wacky results. And though they're very funny, they're not very funny after you've dealt with them for a while, so make sure you wire it correctly. So for these inputs, as you can see, there are 4 inputs for each of these transistors, and we're only going to wire up 1, and I'll show you why in a moment. I'm only going to wire up 1 for right now, but we will wire up the others in a moment. But this is just going to help us lay out the code. Code for this. So we have a blank Arduino sketch that has our void setup, our void loop, so on and so forth. And we are going to just, well, program. So the first thing we want to do is we want to set up our input pins, which are none, and our output pins, which are the ones controlling the LEDs and the ones controlling the transistors. So in order to do this, what we're going to do is we're going to write in an integer for what we're going to, let's call it seg. And seg is going to be an array of 1 by 7. And it is going to look a little bit like this. So 0, 1, 2, 3, 4, 5, and 6. So effectively, 0 is going to control the A, 1 is going to control the B, 2 is going to control the C segment, 3 is going to control the D segment, and so forth until 6 controls the G. The next integer that we're going to define is we're just going to define the pin that actually controls the transistor, and for right now I'm going to call this, I don't know. Oh, what's a good name? Anybody know? Nobody can hear me. Let's just call it num. Actually, no, I'm going to use num for something else. Let's just call it n, int n. And for right now, it's not going to be an array, but eventually it will be. So, for the setup, we'd want to make all our pins an outputs. So, what we can do is write in a for command for a variable n, not variable, integer, sorry, not a programmer, where n is less than or equal to 6. Sorry, yeah, n is less than or equal to 6. I don't know what I'm doing. Yeah, that's right. And then we increment n. And we're going to write pin mode for the segment at n, and each one of these are going to be outputs. So effectively what this does is it starts at n equals 0, and then it writes pin mode seg 0, which would be pin 0 as an output, and then it basically comes back, repeats, n would now increment by 1, so it would be n equals 1, so then we write segment 1 as an output, which would just be 1, and so forth until we reach 6. And then we're going to write a simple command for n, n output. Boom. So this is our pretty basic code, and this is what we're going to build off of. So here now comes a bit more of a challenging part. We need to create an array of numbers. So let's get that set up in a moment. Alright, so now we're ready to work on developing the array so that we can actually control the LEDs. I would like to add, though, I did make a mistake. These are supposed to be squiggly brackets instead of the smooth ones. Just like how, you know, when you're programming, your brain's supposed to be squiggly and not smooth, you know? It's like that. So, in order to... Whoops. Oh, and I also changed N to dis for display because it's better. Alright, so now we're going to write our number integer, which is why I said I couldn't use num earlier. And this is also going to be an array of a 10 by 7 array. So this is going to be equal to a very, very big array. And I'm fairly certain that I do a bit of this. Actually, hold on just a moment. Sorry, I'm cheating. I'm using... yeah, okay, yeah, no, I know what I'm doing. So, here's what we're gonna do. So, yes. So, what this is going to have is it's going to be an array of binary numbers. So, the first one is going to be for a 0. So, what do these ones mean, you're probably asking? There should be only that many. So, effectively, this is going to be for the segment. So, the first one controls A, the second one controls B, the third one controls C, D, E, F, and G. Because when you write a 0 on a 7 segment, the only display that's off is G. That's what we're writing right here. So I'll be back after I've fully filled out this array. You kind of just follow that same rule. Alrighty, so now we're back. So this is what the array should look like, assuming I did everything right. But we will see that once we start testing the circuits. Yet again, this first one is going to display a 0. The second one's going to display a 1. The third one's going to display a 2, so on and so forth, up until the 10th one displays a 9. So that's what this looks like. Now, we've defined our outputs. We've defined our sort of like information. Now what we want to do is we actually want to write our information that we have here, our data, that we have here onto our outputs. So the way that we're going to do this is, because yet again, if we look from left to right, this is A, B, C, D, E, F, G, and this is A, B, C, D, E, F, G from left to right. So this is quite convenient for us, because this means that we can write, when we write num something 0 at seg 0, it will work. So what that looks more formally is we can write a for command for some value n, which is an integer, starts at 0, n should be less than or equal to 6, and n should increment. So this is our basic for command. It's not done yet though. Oh, and that's supposed to be a semicolon, not a regular colon. So what we're going to do is we are going to do pin digital writes, in parentheses, seg of n, comma, num of something n. So what this will do is, yet again, this is a code for a cycle. So on the first cycle, when n equals 0, it's going to write digital write segs at 0, which is the 0 pin, to be whatever num. Let's say we want to write a 0 onto there. is going to write our 0th value in our array, which is the first row here, and it's going to write it at the nth column. So on the 0 cycle, if n is 0, it's going to write a 1. And then on the second one, sorry, that was a notification. How rude of me. Then on the second cycle, n is going to be equal to 1. We're going to write seg1, which would be pin 1, at location 0, 1, which in this case would be 1, and it's just going to do this for every single one. So let's try and do that, right? Second thing we need to do, I almost forgot this actually, is we actually need to do a digital write in parentheses dis, comma, high. So what this is going to do is it's actually going to enable the display to turn on. And that's kind of important if we want to see what we're actually doing, right? And I just need to make sure, yeah, that's good, that's good. Alright. So I'm also going to do one more thing before we can actually upload it, and I'm going to define an integer called val for value, and that's going to be equal to 0, or actually it's not going to be equal to anything. And in the loop here, we're going to write val is equal to 0. And then we're going to write num at location val. And let us save that, and we'll upload it. Okay, sorry, I didn't mean to come back. I actually made a mistake. These should not be semicolons. They should be just regular colons at the end of the array. So make sure you do that, or else you are going to get an error message like I just did. So now we can try and upload it, and let's see if that works. Alright, seems good so far. Uploading. Alright, it's done uploading. I will get back to it. Alright, so now I've uploaded the code. So now let me insert it and see what happens. That's never a good sign. Nothing happened. Oh, you know why? Okay, don't be like me. Don't be a fool. I forgot to add in a ground wire. Okay, so let's see if it works once we've added in our ground wire. Ah, there we go. So, now I have a 0 being displayed on the segment here. And hopefully, if you've been following along, you should too. So what I'm going to do is I'm actually just going to change whatever the value was from a 0 to a 1, and we'll see if that works. Oh, that's not how that's supposed to happen. Okay, hold on. Let me do a bit of troubleshooting. I'll get back to you. Alright, so if you're wondering why it looks ridiculous, it's because the thing that I told you guys not to do at the beginning of this project, which was make sure your wires are wired up correctly, was the one thing that I didn't do properly. So be very mindful of it, or else you'll get things looking like that. Oh, look at that. It's a 1. Oh god, it's not getting in. Hold on a moment. Okay, so now it is wired correctly. So let's just put in a random number like 6 and see if it works. Boom! Look at that. That's a 6 if you ask me. Some may say it's a B, but I say it's a 6. Alright, so with that, we can finally begin on to phase 2, which is swapping between each segment to control them all separately. Let's do it. Alright, so now that we actually have the circuit set up, and we're going to start figuring out how to display a number bigger than 9 on here, what we're going to do is we're going to actually wire up each of our displays. So, the first display here is wired up to pin 8, second display is wired up to pin 9, the third is wired up to pin 10, and the fourth is wired up to pin 11. So these are the pins that we're going to control with the display pins. Alright, so now that we're back, let us write some code for writing onto the other displays. So the way we're going to do this is we're going to convert the display here from a single number of 8 into an array going from 8 to 11, because these are the pins that we're using on the Arduino board, if you remember. And this is going to be a display of 4. Or this is going to be an array, sorry, of 1 by 4. Alright, so what we're going to do now is we're going to kind of sidestep some of this code. So let's take this and we're going to Control C. So we're just going to save it. And we're going to write another for command. I really like my for command, you know? So what we're going to do is we're going to write an integer for m being equal to 0. And what this m is going to do is it's going to, or sorry, I should explain what it's going to do once I've written the code. M is going to be less than or equal to 3, semicolon, sorry, not 31, 3, and m is also going to increment. So what this code is going to do is it's going to start at m equals 0, and then it's going to loop up to m equals 3, which means that it's going to go through each one of these. So the first thing that we're going to do on this is we're going to write whatever the display is at point m to be high. So what this is going to do is it's on the first cycle it's going to write 8 to be high, second it's going to write 9 to be high, third cycle it's going to write 10 to be high, and then on the last it's going to write 11 to be high. So now what we're going to do is we're going to copy in all of the information we have here again with the for command, and we're just going to tab them in. You don't need to do this, I just do it because I think it looks better. There we go. And we're going to add in a delay, let's say 200. And for anyone who may be a little bit unfamiliar with Arduino code, the delay delays in microseconds. So this is 200 microseconds or 0.2 seconds. And the last thing that we're going to do is we're going to write the display at n to be 0. And the reason we're doing this is so that when it goes to the next cycle, the previous display output is off. So it goes 8, then 9, not 8 and 9. So, yeah. Alright, so now we have something that's pretty good looking so far. This would allow us to work, and let's just upload this code to see what it looks like. Oh my goodness, that is really hard to fit in there. Okay. So, sorry, I was being a complete fool again. So make sure that when you have this delay and this digital write part right here, you write it inside of the for command. Hopefully this time it will work. Okay, I see it working. I will show you now. Alright, so this is what that code looks like after you fix it. after I fix it. You probably didn't need to do that. So now what it's doing is it's cycling through every display and it's turning them on and off repeatedly. So this is quite useful. So if we were to display this to be a 1 and then this to be a 2, we could display two numbers independently of each other. Now, right now it's only displaying a 6, which isn't very useful unless you're trying to, I don't know, make a satanic light show. But we're not trying to do that. So let's get back to it and we'll figure out how we can make a 4-digit number and display it on here.
Alrighty, so now we're back to the coding. So, let us figure out how we can convert a 4-digit number into a 4-digit display. So the first thing that we're going to do here is we're going to take this val and we're going to remove it, and we're just going to put it outside of the for loop. And also I'm going to just clean this up a bit. It's very, very messy, very ugly. And I just don't like it being all that close. Anyway, so val, we're going to say val is equal to 0, just for starters. So the first thing that we're going to do is, sorry, I'm blanking for some reason. Right. The first thing that we're going to do is we're going to define a new variable called, we're going to define a new integer of dig. Now, dig, this just stands for digit, and the way we're going to calculate the digit is we're going to write here that dig is going to be equal to val mod 10. So what this is doing is this is taking the modulus val modulus 10, which means that you take val, whatever it is, oops, my AVL, and you divide it by 10, and whatever your remainder is what your digit will be. So what we're going to do then is we're going to say number here is instead going to be digits. We're going to make sure that this is the right val, because it shouldn't be lowercase. And then we're going to say that val is equal to val divided by 10. Now what this is going to do is so that on the second cycle, we're using a different number so that we aren't just displaying the same thing. And we're also going to make sure that we floor this value because, you know, we want it to be floored, so that it doesn't show us a number that's written as something point something. It's just written as something. Hopefully I'll make some graphics for this to make it a bit more easy to understand. And now I'm going to upload it. And you know what, let's make this a bit more interesting. Let's make it 1, 2, 3, 4. Let's see if this works. Would you look at that? It does. Sort of. But you know what? For right now, I'm not going to worry about the problems it has. I'm just going to run with it.
Alright, so the good news is that it is changing the number that we want. So it is being able to control each display independently without, you know, any problems. What's bad though is that I want it to display 1, 2, 3, 4. Oh, and that's what it's displaying. Sorry, it appears that I'm a fool, but this is working. This is exactly what we want. So yeah, that's very good. Ignore my idiocy.
Alright, so now that we actually know that this code works, what we can do is we can take this delay from 200 milliseconds and cut it down to about 2 milliseconds. And what this is going to do is it's going to make it turn them on and off so fast that our eyes can't even register it. And this is going to give it kind of the illusion that all of them are a different number and that they're all turned on at the same time. And what I'm about to do now is optional, but what I'm going to do is I'm actually going to write void, I'm going to create a new void statement. This is just what I like to do. So if you don't want to, you can just skip past this part. But we're going to write void dis for display. So we're going to then take all this code, copy it into here, and then we're just going to delete this. And what this basically will do is it'll just kind of shorten the amount of code. We can upload it and observe the fruits of our labor. It's not working. Well, oh, you know why? Because I didn't add the display function here. So let's see. Now we can observe the fruits of our labor. Do they taste good? They taste good, let me tell you. Let me show you. See, that's beautiful.
What did I tell you? The fruits of our labor taste absolutely delicious. We can make this say any number we want. Well, okay, maybe not any number. If it's more than 4 digits, we can't display it. But we can display any 4-digit number we want. You know, maybe you want to be a quirky and display 2020. Actually, that's a bad year. Let's display 2020. Let's display 2015. That was a good year. I think I would have been too young to remember it. Alright, look at that. We can see 2015. There are some fragments, as you can see, but there are ways, if you were to add like a small cover to this, it would significantly negate it. But that is pretty nice, I'd say. So, I hope you enjoyed this video. I'm going to have the code in the description, and I'm also going to leave a circuit diagram, hopefully at the end, so that you can copy off of it in case some of my ramblings didn't make sense. I hope you guys enjoyed this project.